Hey everybody, welcome back to another episode of my channel. Today we are going to be going over the concept of active reconnaissance. And as always, we're going to be doing this in real time, so I haven't even started up the machine yet. We're working with TryHackMe, as it's one of my favorite platforms. We're going to find the room that we're going to be working with right now is going to be in the CompTIA Pentest Challenge. And it's going to be right under here under information gathering and vulnerability scanning. We're going here, and I've done this room in the past, so I'm going to walk you through all the steps, and I'm going to make it so that hopefully you understand it when you're at the end of this deal. So yesterday, or in our last video, we went ahead and we spoke about what passive reconnaissance is. Today we're going to be talking about what active reconnaissance is. So we're just going to go through the introduction. As we learned in the previous room, passive reconnaissance lets you gather information on your target without any kind of active engagement, no active connection. You're watching from afar and collecting information publicly available. Active reconnaissance is completely different. This is where you're going to be engaging with the system and the target. This target can be a phone call, a visit to a target company under the pretenses to gather information. And then they give you the analogy. Think of it like you're closely inspecting the windows or doors. Hence, it is essential to remember not to engage in active reconnaissance before you have signed legal documentation and authorization to work. So you definitely want to have a scope of work going before you guys do this. From a pen testing perspective, you're not going to be the guy who deals with this. That's going to be project management. But you definitely don't want to get busted, so you want to make sure all your ducks in a row. Okay, so in this room, we focus on active reconnaissance. Active reconnaissance begins with direct connections made to the target, such as connections might leave information, logs in the client IP address, time of connection, duration of a connection, amongst other things. However, not all connections are suspicious. It is possible to let active reconnaissance appear as regular client activity. So consider a web browser. No one would suspect a web browser connected to a target web server running target web server among hundreds of others legitimate servers or users. You can use such techniques to your advantage when working as a part of a red team / attackers. And you don't want to alarm the blue team / defenders. In this room, we'll be focusing basically on 3 different tools. Afterwards, we discuss the benign tools such as ping, traceroute, and telnet. So without further ado, let's jump right in and get started on this. So one way you can get into actively testing a network is by testing the website itself, or the web browser as it is. The web browser can be a convenient tool, especially that it's readily available on all systems. There are several ways where you can use a web browser to gather information about a target. On the transport level, that's a networking term. If you don't know about it just yet, I recommend you guys getting into some basic networking. The browser connects to port 80, which is a HTTP port, a TCP port 443. These are the 2 that deals with web pages. It's secure. This is insecure or unsecure website, and the TTPS basically stands for secure. Since 80 and 443 are default ports for HTTP and HTTPS, the web browser does not show them in the address bar. However, it is possible to use custom ports to access a service. For example, HTTPS, your loopback 127.0.0.8834 will connect to 127.0.0.1, your local host, at 8834 via HTTPS. If there is an HTTPS server listening on that port, we will receive a web page. So while browsing a web page, you can press Control Shift and I on a PC or Option Command and I on a Mac to open the developer tools in Firefox. Now, developer tools is going to be extraordinarily useful. So I definitely recommend you guys getting to know those just a bit. So, restart checkbox here. Just scrolling down here, checking to see if we did started an attack box just yet. Yeah, okay. So, and pretty much across the board, web browsers have somewhat of the similar tools. Developer network assessment is going to be able to wait for you to inspect and interact somewhat with your web page. So, as it goes through, developer tools let you inspect many things that your browser has received in exchange with a remote server. For instance, you can view and even modify the JavaScript files, inspect the cookies set on your system, and discover the folder's structure of the site content. Below is a screenshot from Firefox Developer Tools. Chrome DevTools is quite similar. So this is what it would look like. So this would be a login page, and if you were to go inspect or to inspect the page, or right click on the website and look for inspect, you would come up with this debugger developer tool. So, and then each one of them has their own thing in which they do. Each one of them gives out a little bit of information, and we'll get to that in another video. There are plenty of add-ons for Firefox and Chrome that can help penetration, and here are a few. Fireproxy, which you're going to be using quite a bit if you're going to be using Burp Suite, which you will be using Burp Suite. It lets you quickly exchange the proxy server you're using to access the target website. This browser extension is convenient when you are starting to use tools like Burp Suite, or if you need to switch proxy servers regularly. So it's basically just allowing you to use a server somewhere else in a different location that you basically proxy onto. So that's the basics of a proxy server. User agent switcher manager gives you the ability to pretend to be accessing the web page from a different operating system or a different web browser. So in other words, if you're running Mozilla, you can you could act like as though you're working with, I don't know, Chrome or Safari or anything else. Wapalizer, is definitely another one you want to look into because it's a one-site kind of. It's an extraordinarily beneficial add-on. And what it does is it provides you insights about the technologies used on visited websites, such extensions is handy primarily when you connect all this information while browsing on the website, like any other user. A screenshot of Web Apps Appalizer is shown below, and you can find Web Appalizer for Firefox right here. So this is going to be the information that it pulls up for you. Whenever you connect to a website, it's going to be pulling up the CMS, what's running it, what's the management tool, what's the operating system, the CDN, what's going to be Cloudflare, and so forth and so forth. And this is information you're not going to have to go looking for if you're using Web Appalizer, and it's going to be because it's going to be readily available. You can see that it pulls up the information about the web server, the database that's running, miscellaneous, which would be HTTP2, and all various goodies that you're going to be coming in contact with. And it's just one of those easy one-stop shopping kind of apps, and I recommend that you kind of look into it. Browse the following website. Interesting. And ensure that you've opened your developer tool on the on the attack box. Let's see if we can grab this, copy this, because I just opened it in my. By clicking on it, it just opens up into your Mozilla Firefox on your local host machine. Coming over here, accessing it in my Firefox on my VM allows me to stay within the Try Hack Me platform and analyze it from here. If it will allow me to do that. Sometimes you have to drag it over to the clipboard and drag it from the clipboard, copy it, and paste it. Let's see if that works. Yep. All right, so from here, we are going to be looking into this using our developer tools. Figure out the total number of questions. I'm not understanding this, but as you can see right here, it's the inspector O, inspector A, Firefox, and or the browser on your computer. Using the developer tool, figure out the total number of questions. Okay, well, I'm assuming it's somewhere in there, right? Debugger. Let's full size this bad boy. Is this okay? Great. So that was 1, 2, 3. Sync acknowledge. I don't know if it would be sync acknowledge. Just looking for the handshake. Yeah, I didn't think so. Acknowledge. No. Okay, done. Yeah, me too. Oh, there you go. I guess that's the. I don't even know how many that was though. So that is not what I was looking for, but we gotta figure out where we're gonna put it. So that flag is here somewhere, only because I'm looking for it. I stumbled upon it. I'm not letting it go. Might as well. I'm putting it all together. No answer there. Okay. Going back. That's a horrible habit, by the way. I really wouldn't recommend you following what I just did. Nope. Okay. I can't imagine where it could be. Honestly, this has been such a long time since I've done this that I've forgotten exactly what you're supposed to be doing. So this is kind of a nice refresher for me. That is so odd. Locate the JavaScript file, inspect the file, and figure out how many total number of questions. Well, we can count it, couldn't we? Okay, local. Let's just locate the file, JavaScript file. You're not what I need. I need you. TCP chatter. Okay. Come over here, and this is what it looks like in Mozilla on my host computer. So, according to this, I have to look for the JavaScript OS. No, debugger. No. JavaScript. And then 1, 3, 2. How many of these are there? 8. Okay, so what's that? Okay. If you guys don't know what I just did there, I'm just going to explain it to you guys real quick. From here, I went to the debugger. This has all the information here on the sources, and I went through and cycled through. Hey, buddy. And I just kind of just went down and checked the JavaScript to see how many times that this cycled through, and that was it. And as you can see, there are 8 interactions. So come over here. The answer is 8. I really kind of want to know where that ping chatter is. Start machine. Watch it be here. Close you. I'm going to put this. I'm going to put this somewhere. So as always, I always stress best practices, even though I don't do them sometimes. I'm going to drop this into my own little note, but I'm going to sit here and suggest that you guys do a make directory anytime you do any kind of pen testing. So this is going to be active, and this is just good practice. So as you can see, where are you? Yeah, okay, so that just basically makes a folder. So we're going to cd into active, and I'm doing that so this way when you start to work, it keeps everything in line, and it's just good practice. So now I want to go to nano flag.txt. Right, and let's see if I have it still. Yeah. What was it? HTML TCP chat. Okay. THM squiggly bracket TCP underscore chatter. Okay. Hold on to that for later because I know I'm going to use it. We X out of it. We X out of it. We say yes. Put it right there, and we CD back out. Okay. We're going to start the machine. This is going to actively make a attack box in which we're going to be attacking. So stay with me. For brevity's sake, I'm not going to go through all the reading, but ping is a pretty standard command, something you really should know. Ping is probably one of the most fundamental key commands to know if a machine is up. And it's just basically sending a ping as like a, hey, how are you doing? Are you available? And that's basically it, right? That's what a ping command is. So as soon as this guy is up and going, we will have our target and we will ping it. So in simple, ping command sends a packet to a remote system, and the remote system says, hey, I'm here. By the way, you can include that. This way you can conclude that the remote system is online and the network is working between 2 systems. Just bear with me. Okay, do we have the machine just yet? We have a machine. Yes, okay. So right here, the first thing we're going to do is we're just going to send a ping command, see whether or not the machine is up. And that's just basic standard practice, whatever you want to do. I mean, I wouldn't even really call this active reconnaissance, even though it is. It should be handled as though it is active reconnaissance. However, you know, all this is just showing if the site is up. You can actually just go to the IP address too and see if it's there. Okay, you're going to go caret C to close that out, or Control C, or ping host name. Ping host name. I think it's in all caps. Host name. Oh, we're moving on. Yeah, so it needs a host name to resolve to. So not worried about that. Let's say you don't want ping to go rocking and rolling all day long. You just go ahead and type ping C, which would give you just X amount of, just a few. So let's say you wanted to do ping 5, so you only wanted to send 5 requests after the C. So 67, 177, and 191. That's going to send 5 requests. Correct. And we got our guest here today. This is my boy Zero. What you got? Stay away from them. I will put you right back down. Sam. Okay. So then, yeah, that just sends 5 packets. 5 packets come back, and it tells you the state of the packet, whether it is good or bad. So the next one we're going to do is a ping N. If you just want to send 10. So apparently that is the same as if you want to send 10 packets to 10. What was it? 6, 7, 177. And that's going to send 10 total packets. What you doing, Munchkin? All right, and as you can see, that the machine is rocking and rolling just the way it's supposed to be. So that's ping in a nutshell. It's active. It just shows that it's there. That's all it is. Not much to be worried about with it. Is that 10? It just keeps going. Okay. All right. You gotta go down, buddy. You're not helping me out in any way. Okay. So, moving on, we go through, and that's basically ping. So let's see what it has to sit here and say. Generally speaking, we don't get a ping back. Basically, this is actually used more in networking to see if the connection is made. Which option would you use to set the size of the echo request? So which option would you use? Would you use the text C? All right, no. Use man ping. Okay. I didn't even know there was a man ping. Ping. Man obviously stands for manual. And size data. All right, so let's find it. Use for IPC, set the size. See, so C would be the count. D would be debug, print stamp, flood ping. That would be considered a DDoS attack, so let's not worry about that right now. Show help, interface, preload, Come on now. Give me the goods. Okay, so. No. Set the size of it. Pattern, quartile. Is it going to be S? Packet size. There it is. So I never actually knew that. I also didn't know that there was a. I actually didn't know that there was a ping manual. What is the size of? What is the size in bytes? 8 bytes, right? What do you got? What you got? What, 8? Why are you? Yeah, there you are. Hey, how about that? Does Microsoft Windows Firewall? I'm going to say no because it's an ISCP packet. I guess I was wrong. Okay, so deploy the VM for this task and using the attack box. How many? Really? It's not. Alright, so this asks deploy the VM and using the attack box, issue the command ping C10, which issues 10 on the count. So how many ping requests are you gonna get? 10. Pretty simple on that one. Moving right along. We got pretty simple questions. So cool. So what is traceroute? Traceroute is basically as you send a signal, it's going to go through many routers, and every router has its own IP. So that basically traces the route of your IP signals. Pretty straightforward. As the name suggests, traceroute command traces the route taken by packets from your system to another host. The purpose of the traceroute is to find IP addresses of the routers and hops that the packet traverses as it goes from system to target. This command also reveals the number of routes or routers it hits between two systems. It is helpful as it indicates the number of hops/routers between your system and the target host. So that's basically trace route in a nutshell. We're gonna go ahead and quit this guy. We're gonna go quit this guy, and we are gonna clear. All right. We are in traceroute still. So when you want to use traceroute in, what is going on? Okay, hold on. So when you want to use traceroute in Linux, it's going to be traceroute. When you want to use it in Microsoft, it's basically traceroute. All right, and argument without anything typically brings you to the help page. But we are going to trace the route of our IP address, one given to us by Try Hack Me, and we go 991. All right, so 30 hops, and Windows trace route, blah blah blah. So there's no direct way to discover the path of your system from your system to the target. We rely on ICMP to trick the routers to reveal their IP addresses. We can accomplish this by a small time to live in the IP header field. Although T in the TTL stands for time. TTL indicates the max number of routers, hops the packet can pass through before it is being dropped. All right, so that's pretty straightforward. The following figure shows that each time a packet passes through a router, the TTL value is decremented by 1. So as it gets passed through, it loses 1 and loses 1 and loses 1. So if it's going to, 5 routers, it's going to lose, 1 on each one of those. Okay. However, TTL reaches 0, it will be dropped. And the ICMP, time to live, exceeded would be sent back to the original sender. So this is all basic networking stuff. So if it goes through here, it doesn't make if it loses all of its packets, by the time it gets here, it goes back to the sender itself. So let's go one more time. Traceroute to Try Hack Me. .com, and there you go. This is different because this is our attack box, which technically doesn't really have much because it's a VM, so it's not really on the web, even though it's being used for hosting purposes. Accessing Try Hack Me, however, does, because Try Hack Me is an actual site. Even though we're on it, it's still taking this VMware and it's running through all these routers in order to get to this last one. So as you can see, it starts here and ends on 9. And if you were to look through all the packets being sent, it would have been diminished by 9. So moving on. We notice that different runs might lead to different routes taken by packets. Trace like A. So yeah, you see this one has 14, as mine only has 9. The output below has 14 numbered lines. The line 12 is this IP. Yeah, so this basically just goes and explains what I just said. So It's basically just sitting here saying how many times it's being lost. Finally, the first time of the output, we can see that the packets leaving the attack box take different routes. We can see 2 routers that correspond to the time to live, being 1. Our system never reached the 3rd expected ICMP message. That looks like your problem. Okay, so I guess we're running the same machine again. I still got 9, and it's rocking back the same IP addresses, so I don't think there's going to be any distinguishing differences here. In the second run, traceroute programs, we noticed that the packets took longer, going through 26. Did they do something different? Traceroute, nope. What is the IP address of the last hop? Okay, 172.66.164.2. That doesn't make sense. Might not have to do that here. Let's go over here. The last hop. Copy that. And we're just going to drag this guy. Put it there. Okay, same thing. In traceroute B, what is the IP address of the last boom before reaching try hack me? Same thing. That's this guy right here. Copy that guy. Come back here and drop it in. In traceroute, how many routers between the 2 systems? Boom, it's going to be 26. So it took 26 hops to get to where it needed to go. That's really it. So start the attack box, tax 3, and yeah, so that basically sits here and says, just try it on your own machine, basically. Telnet is an interesting thing you will find in the field from time to time. And let's go over it. So Telnet is Tel-type network. It was a protocol developed in the 1960s and the start of the internet with the remote systems via command line, command line interface, the CLI, hence the command Telnet. That's what you typed whenever you need to access Telnet. Pretty simple. It uses the Telnet protocol for remote administration. The default is port number 23. From a security perspective, Telnet sends all data, including user name and passwords, in clear text. So that means it's not encrypted, it's not obfuscated, it's pretty much exactly how you're going to see it. Setting in clear text makes it easy for anyone who has access to the communication channel to steal the login credentials. Then the secure alternative is Secure Shell. For the most part, everybody does use Secure Shell, SSH. So older things use Telnet. It's still in use today. However, Telnet client, with its simplicity, can be used for other purposes. Knowing that Telnet clients rely on the TCP protocol, you use Telnet to connect to any service and grab its banner using Telnet 10.77.191. Right, and then we're going to use port 80 because it's down here. You connect to the service. Let's say you want to discover more information about a web server listening to on port 80. We can connect to the server at port 80 and then communicate using HTTP protocol. You don't need to dive into HTTP protocol. You just need to issue get HTTP 1.1 to specify something other than the default index page. You can use get page HTML HTTP 1.1, which will request page HTML. So we're going to run that. All right. We're going to type in get. That's not going to be right, right? Slash. I don't think that's right. Slash. Oh, and there it is. So that's going to be the header that's associated with this page. So, Apache 2. It says it's Nginx. Interesting. This came back with a different set of instructions. As you can see, it says connected to 1067.177. All right. 191. Connected to it. Escape character is the caret. Get. Oh, maybe that's what I did wrong. All right. There we are. Going to go get. HTTP 1.1. Anything? Nope. Right. Interesting. Okay, so of particular interest for us, discover the type and version of the installed web server. Nginx. In this example, we communicated with a web server using the basic HTTP commands. If we connect to a mail server, we need to use proper commands and protocols such as SMTP and POPs3. So start the machine. If you're not already done it, open the terminal and use Telnet client to connect to the port 80. What is the name of the server running? Okay, so I wasn't too far off. Apache. Oh yeah, what is the version running? Well, that's going to be pretty simple. 2.4.61. 61. And there is the and that's it. That's Telnet for you. We'll go into Telnet more in depth as we go through many more series, but this is a very, very basic. It's very simple, and obviously this should be broken down into 2 different videos, so it's not extraordinarily long. However, here we are. We're on the last one, so let's finish it out. All right, so Netcat, and simply NC, which is the Swiss Army knife of networking, pen testing. Remember that. Network, or simply NC, has different applications and can be great value to a pen tester. Netcat supports both TCP and UDP protocols. If you don't know what those are, we'll have to discuss those in a different video because just too much to take in right now. And it can function as a client that connects to a listening port. Alternatively, it can act as a server that listens on a port of its own choice. So it basically could be a listening device, as well as it could be it can connect to and it can listen to. So it makes it a very useful choice for pen testing. All right, so hence is a convenient tool that you can use as a simple client or a server over TCP or UDP. So you're going to be using Netcat a lot. It's pretty standard, so definitely get ready to use it. First, connect to it by simply typing in NC, which stands for Netcat, or 10.67.177.191, and we're going to connect to it with port 80. Now watch, nothing's going to happen for me. So while it connects, I'm going to read it. First, you can connect to the server as you did with Telnet. To connect to the battery using NC, IP address, which is quite similar to our previous Telnet port. Note that you might need to shift enter to get the get line. I don't think that's going to work here because I didn't get anything yet. Get HTTP 1.1. Oh, how about that? Bad request. This one's supposed to be okay. So, did send over some information. Not the information we kind of wanted, but it did send over the information. Let's try it with the. Nope. Get rid of it. No. There it is. We'll go Netcat and we'll go Shift Enter. Nope. 10.67.77.191.80. Get HTTP /1.1. Yeah, bad request. Okay, cool. In the terminal above shown, we use Netcat to listen on our IP and our port. Next, we issued the GET command for HTTP, and we are specifying the target server that our client supports HTTP version 1.1. Okay. Finally, we need to give our. We didn't get that. We specified. Finally, we need to give a name to our host. So we added a new line of Netcat. We did not have to do that. I don't think we did do that anyway. Netcat. Let's see what happens when we do that. Okay. I always enjoy doing these after so much time too. Like one big. Yeah, I didn't think that was gonna work. It's like one big refresher course. Okay, so you can name your host anything. Has no impact on this exercise. I didn't have to. I didn't also get my 200 callback, so who knows? On the server system where you want to, okay, stepping back, based on the output, we have Apache, so I don't know, this might be out of date rating. We can tell that the port 80, we have Nginx version 1.6.2, standing for incoming connections. Why did I do that? That's so weird. Interesting. On the server, this is pretty much going to be the standard what you use pretty much all the time. On the server system, you want a port opened and to listen on it. Let's step back for a second. You can use Netcat to listen on a TCP port and connect to a listening port on another system. All right. So on the server system, where you want to open a port and listen on it, you can use Netcat LP1234, or better yet, Netcat NC TAC V NLP 1234, which is the equivalent to NC, which would be Netcat TAC V, TAC L, TAC N, TAC B, and the port you're going to specify. As you would remember from our Linux room, which we didn't do just yet, the exact order of the letters does not matter as long as the port number is preceded by the P. So you type in any one of these as long as the P and the port are next to each other, right next to each other. So the L is the listening mode, the P is the port, the N is the numeric value, and the V is the verbose output. You can do also VV, which is very verbose, and key, which is key listening after client disconnects. Notes. The option P should appear just before the port number, and the option N to avoid DNS lookups and warnings, which basically means it won't flag the system. So, as we are here, we are going to get into the meat and potatoes of this fun stuff. Okay, so on the client side, we would issue the NC.10.67.177.191 and port number. Here is an example of doing NC echo. Let's just do 1, 2, 3, 4. All right. Tac. My message. Yeah. Is that right? Oh, so 21. Okay, so we're gonna go over here. We completely botched this one up, but I guess we're gonna be doing the what am I missing? On the client side, we issue the command. We have to open up another one for this, right? Okay, you achieve this with the NC 21. That's not right. This is, I think I should be open. Start the VM and open the attack box. Once you, yeah, so I think you'd have to actually open another one, right? So that's gonna be your listening port. We're gonna do another terminal, right? So we're gonna type in NC dot 10.67 67.171.191 and we're gonna use port 21. Right, and then here, so the guy listening. That's right. Okay. Didn't think so. I'm forgetting something here. All right, so what's the path box? Oh, we just did all this stuff. Save room, recommended options. All right, so we're gonna connect to it. According to this, says on the client side, you would issue the Netcat, right, and your port number. Oh well, that's probably the big portion of it. 99% of my problems are what exactly? Goddamn right. It is. Okay, of course not. Of course not gonna work. All right. After you successfully establish connection to the server, that cat 67 dot dot dot. Here's an example of it using this. Didn't think so. Okay, so we're not missing anything here. All right. Okay, well. ALMP. Okay, so what the hell am I missing? What is the version of the server running? Yep. Nothing. Nothing. So we're gonna exit out of this. And doesn't make any sense. Dot 10 dot 67 Sweet. This isn't gonna work, but whatever. Okay, so put it all together. What is delivered? Nothing here. Open another one. Start the VM and open the attack box. Once the attack box loads, use Netcat to connect to the VM port 21. We did that. What am I missing? Nothing's coming through. Yep, nothing. Nothing. This one did not explain it well enough. Let's go see if there is a write-up. 92% done. Come on now. On the service system. Bye. Am I missing something, or did they not explain this correctly? On the client side, you would issue the Netcat, right? Let's do this. Let's just look through all of these. Telnet, blah, blah, blah. Okay, so I didn't actually do that. Yeah, so it's not asking me anything different. It's just not letting me do this. So, we're going to cut this out of here. We're going to go. Yeah, not letting me work. This is a bunch of crap, dude. It's not letting me do this. Sweet. Six, 21, right? Dude, you're killing me, Smalls. It's not letting me do what I'm supposed to do. NC, Netcat, right? VNLP. Nope. Not giving me no love. Huh. Well, it wouldn't be a room if I didn't know, if I didn't mess up, right? Let's see something right quick. I have config. Right, right. Well, God damn it. Okay, 6.4 now. Oh. .0.17. All right. Well, I'm not going to spend much more time on that. We're going to have to deal with Netcat a little bit more as we move through. So, most definitely make sure you guys keep an eye on it. And as always, if you like what you like, if you like what you saw, like, comment, subscribe, and I will catch you in the next one.